Hello friends, welcome to Maths Academy. I am Nur Alam, Maths faculty of Maths Academy. Today we are going to learn the some basic properties of divisibility, which is very helpful, and the question coming in IOQM number theory from this topic. So now consider that let A, B, C, M, X and Y be integers. Then property 1, if A divides B, then A divides BC for some integer C. Number 2, if A divides B and B divides C, then A divides C. If A divides B and A divides C, then A divides Bx plus or minus Cy. Bx plus Cy. Property 4, if A divides B, then mod of A lesser than equal to mod of B, provided B cannot be 0. 5, if A divides B and B divides A, then A is equal to plus minus B. Number 6, A divides B if and only if AM divides BM for M not equal to 0. Now the proof of these properties are very simple. We can easily prove it, and proof is not required but in exam, but if you do the proof you can have the idea how the result came. So now going to proof one by one, and proof are also very simple. So proof of 1, since A divides B, so we can say that there exists one integer q such that B is equal to AQ for Q belongs to integer. Now if I multiply both sides by C, so we have BC is equal to BQ times of A. So this will again implies A divides BC. So this result is proved. Okay, now so this is proof that A divides BC. Hence proved. HP means hence proved. Coming to the next question. Next theorem. This says that if A divides B, B divides C, then A divides C. So since A divides B, so we can write as B is equal to Q times of A for some Q belongs to I. Again B divides C, so we can say C is equal to B times of some Q1 where Q1 belongs to some integer I. So this is equation 1, this is equation 2. So I put the value of here B is what we know that B is equal to QA. To put the value of B here in the equation 2, so we can write C is equal to QA into BQ1. So this I can write Q times of Q1 B and then A. So this is nothing but integer, so this will imply A divides C. So hence proved. Result 2 we have already proved. Now coming to the next part, A divides B and A divides C. implies that a divides bx plus cy, where x and y are the integers. So result 3 we can prove here. Result 3, proof of result 3. Since a divides b, so we can say b is equal to q1a for some integer q1, and a divides c, so we can write c is equal to q2 times of a for some integer q2. So now bx plus cy, this thing we can write value of b is q1 times of a, value of c is q2 times of a. So from here we can write q1 plus q2 and outside is a. So this is nothing but bx plus cy. So bx plus cy some integer times of a, so this will imply a divides bx plus cy. So hence proved. Similarly, you can prove these results 4, 5 and 6. So now coming to these results, fourth, if a divides b, then a is smaller than b or equal to b. Condition is b cannot be 0. B cannot be 0. So now we can write the result of 4 here. Result of 4 we can write here. So a divides b we can write as b is equal to a times into q, where q is some integer. So now we can take mod of b is equal to mod of a times of mod of q. Achha, since b is not equal to 0, so mod of b cannot be 0. Now one integer is the product of the two integers. One integer is the product of the two integers. So since left hand side is not 0 and the divisor is not 0, so this will also imply q cannot be 0. Q cannot be 0. So if q is not a 0, q is an integer. Q is an integer, and if you multiply that integer with a, then we get b. So either what will happen, if q is 1, then a and b are equal, or if q is 2, if q is 2 or more than 1, then a should be the integer which is less than b. Otherwise result will be more than b. So what possibility of q has? Since q is not equal to 0, q is the integer, so we can say that mod of q is greater than equal to 1. Mod of q is greater than equal to 1 because q may be the negative integer, we take the modulus. So now from here what we can say that if I multiply both side by mod of a, so this will be mod of a. So, but this part is nothing but mod of b. So mod of b is greater than mod of a. That means divisor is always lesser than equal to dividend, or less than dividend or equal to dividend. Okay, now so this result is, I think, hope clear up to the 4. Coming to the result 5, since a divides b, so we can write mod of a lesser than equal to b, less than equal to mod of b. Since b divides a, so we can write mod of b less than equal to a. So if I combine these two, so we can write mod of a is equal to mod of b, or you can say that a is equal to plus and minus b. Okay, now so this result I have given you as a homework. Try to solve result 6. Okay, now coming to the problem part. So we do some questions which are very easy. Problems. Question number 1. If 7 divides 2 plus a and 7 divides 5 plus b, then prove that 7 divides a plus b. Since here you notice that a and b are in the addition form, so what we do, we use this criteria that we know the property says that if a divides b and a divides c, then we can write a divides bx plus cy, where x and y belongs to integer. So in our case I am taking b is equal to 1 and c is equal to x and y both are 1 I am taking. So if I take x and 1, x is 1 and b y is also 1, so I am getting what? A divides b plus c if x is 1, y is 1. So that means 7 divides these two numbers separately. So we can write by using this property 7 divides sum of this number 2 plus a plus 5 plus b. So now 7 divides 7 plus a plus b. Since 7 is always divisible by 7 and we know that 7 is always divisible by 7, so now we can say that 7 divides 7 plus a plus b minus 7. So these two cancel out, it will implies 7 divides a plus b. So hence proof. Since a number 7 divides 7 plus a plus b and 7 divides 7, so therefore 7 divides their difference also. So in this property we are taking if x is 1 and y is minus 1, so we get y is minus 1, then we get a divide b minus c. Okay, now? So this property we can use in a different way. Any doubt you can write in my inbox. Now coming to the next question, question number 2. Interesting questions. Question says that if 6 divides n square plus 3n plus 2 and 0 lesser than n, 0 lesser than n lesser than equal to 100, find the number of positive integer n. Find n belongs to I plus. Find the positive integer n. The question is what? If 6 divide this whole expression, and restriction on n is given 0 to 100, then what are the values of n? So first of all, we know that 6 is nothing but 2 into 3. So if 6 divide this expression, so we can say that 2 divides this expression n square plus 3n plus 2. At the same time 3 divide this expression n square plus 3n plus 2. Because we know that if a divides b and a divides c, then not a divides c, if a divides some integer b and c divides that integer b, so we can say that ac divides b if provided their SCF is 1. So here we are going to use this result. Since the product is 2 into 3, 6 divide that number, so if I do the prime factorizations so that their SCF is 1, 2 and 3, so individually they will divide. Now after that what we will write? Do the factorization of this number, so we have n plus 2 and n plus 1. Here we have 3 divides n plus 2 and n plus 1. Here you know that these are the product of two consecutive integer. Product of two consecutive integers. What we know about it? If you choose any two integers which are consecutive, one of them is even, other is odd. So here we can say that this expression is always divisible by 2, whatever the value of n you put. So this expression is always divisible by 2, and at the same time the expression is divisible by 3. So since this expression is divisible by 3, so what will happen? So we can say that only for what values of n this expression will be divisible by 3, because it is divisible by 2 for any values of n, but it is not divisible by 3 for any values of n. So what are the values of n that we are wanted to know? So now our expression, if I say here it is n plus 1 and this expression is n plus 2, if I call this expression is alpha and choose the alpha, choose the different values of n. When n is equal to 1, then alpha is equal to 1 plus 1 2 and 1 plus 2 3. So now if I choose n is equal to 2, then alpha is equal to what? Alpha is equal to 2 plus 1 3 and 2 plus 2 4. Okay now, if I take n is equal to 3, then alpha is equal to 3 plus 1 4 multiply 3 plus 2 5. So you notice that it is not divisible. So when n is 3 or the multiple of 3, then this product is not divisible by 3. Both are the number which are not divisible by 3. So if n is equal to 3k type number, 3k number, you can say k belongs to I, then 3 does not divide this expression. So 3 divides this expression only when n is not a multiple of 3. So that means 3 divides this expression only when n is not equal to multiple of 3. So now from 1 to 100, if you are calculating what are the multiple of 3, so if I form a set A which contains all the multiple of 3, 3 6 9, in this way I have 99. So can I find out the cardinal number of this set? That is our target. So this number you notice that are in AP. Okay now, these number are in AP, and the first number is A, that is the first term, and the common difference is same. So you know that n is equal to, directly you can divide the last term. So 33 numbers are there. So cardinal number of the set is 33. So 33 are the numbers which are the multiple of 3 from 0 to from 1 to 100. So from 100, if I subtract this number, so we are getting 67. So these are the number which are not here. These are the number which are divisible by 3. 67 numbers are there. So required number of n is 67. So 67 values of n are there from 0 to 100, excluding 0, including 100, which are divisible by the number 6. Now next question number 3. This question came in pre-RMO 2014. Question is, find n if 8n divided by is integer. Where 1 less than equal to n less than equal to 2014. So this is the integral value or the range of n, and we have to find n so that this number is an integer. So now we assume that this value is alpha, which is integer. Alpha is integer 8n by 9999 minus n. Dividing numerator and denominator by n, so we have 8 by 9999 by n minus 1. So now here in the numerator we have the pure number without n, that is 8 only. In denominator contains the n term. So since alpha is an integer, so what we know that this denominator should divides this 8. That means n 999 by n minus 1 divides 8. So we can say that this will imply 9999 by n minus 1 is a factor of 8. But here we are dealing with the positive factor because the range of n is given, the maximum value is 2014. So therefore this denominator is also positive, 8 is also positive, so alpha is positive. So here we are consider only the positive value of these factors. So positive factors we have to take. So now 9999 by n minus 1 should be plus 1, because 8 divided by 1 1. If you take 2, no problem. If you take 4, or you can take 8. So 9999 by n is equal to 1 plus 1 2, 2 plus 1 3, 4 plus 1 5, 8 plus 1 9. So 2n equal to 99999. So n we can write as 9999 by 2. Dividing by 3 you have 3 3 3 3. Dividing by 5 you have 1 2 3 4 by 5. Dividing by 9 you have 1 2 3 4. So what we notice that since n is a number which is lesser than 2014 and greater than equal to 1, so it is not more than 2014. So therefore we have to take only this value. So these will be the suitable values of n. This one, this value we can take, and these are the non-integral, non-integers, so we can take. Hope all of you understand this concept. Now coming to the next question, question number 4. Show that for all integers n, we have to show that 169 does not divides this expression n square plus 2n plus 14 for n belongs to n. For all positive integer, 169 does not divide this number. 169 does not divide this number. Okay now. So when you are dealing with this kind of expression, so always remember that 169 is a square of 13. So here the constant is 14. So you have to adjust in such a way so that you are getting as a constant in the expression. Your expression must contain 13k or 13m type of constant. So in your factorizations or in your expression, you have to manipulate in such a way so that the constant will be of the form 13 types of m, because here is 169 which is the square of 13. So we want to include this number as a constant in my result. Okay na? So now 169 you have to prove does not divides n square plus 2n plus 14. So this expression I call alpha. So my alpha is n square plus 2n plus 14. So since this number is a perfect square, I am going to form one perfect square in the expression. So this will be. So now it is 1 n plus 1 whole square plus 13. So two cases arise from here. Either this term is divisible by 13 or not divisible by 13. So case 1, either 13 divides this number n plus 1, does not divide, or 13 divides n plus 1 this number. So now in case 1, if 13 does not divide this number, so that means n plus 1 this number is not equal to 13k type number, where k is, you know, that integer. So therefore n plus 1 whole square, this expression will not be equal to 169k square type of number. So you can say that 169 does not divides n plus 1 whole square plus 13, this type of expression. Now the question arises, n plus 1 whole square, this expression is not divisible by 169. So now you want to add, if you add 13, the question arises, again the expression will be divisible by 169 or will not be divisible by 169. That is the main part. So here it is a perfect square number. Notice that perfect square number. So you are dealing with a perfect square number, and if you add something here, so you see that the remainder is 13. and if you add a number 13, the expression may be a perfect square, may not be the perfect square. Okay now, so if I add here suppose 13, so if I add here 13, well, what will happen if I add here 13? So our expression will be n plus 1 whole square plus 13. Okay now, so now you are getting another perfect square number. So this perfect square, so if you have the two perfect square number, consecutive perfect square number, so and their difference is 13. What I am saying, if you have this type of number, suppose lambda plus 1 whole square minus lambda square, their difference is 13. Okay now, so now what will be the value of lambda? What will be the value of lambda? So that you are getting the 13. So we consider here lambda is suppose 1, so we have 2 square minus 1 square, difference is 3. Lambda, if you are considering 2, it will be 2 plus 1, 3 square minus 2 square, so this will be what, 5. So lambda is 3, then 4 square minus 3 square, so it will be 16 minus 9, 7. Then lambda is 4, so you have 5 square minus 4 square, that is 16, so you are getting 9. Okay, now lambda is 5, so you have 6 square, then 5 square, then you have 11. When lambda is 6, that means 7 square minus 6 square, so you have 13. So you can say that 7 square will be equal to 6 square plus 13. So now what we notice that this number after adding, if it is a perfect square, but your perfect square is only what, 7 square. So if it is happen, we assume that you are getting a perfect square, but this number is very less than, where you are not, say 169 will not divide this number. So 169 will not divide 7 square. But after adding 13 is not a perfect square, but after adding 13, if it is not a perfect square, n plus 1 whole square plus 13, if it is not perfect square, then the question of divisibility by a perfect square will not happen, because a non-perfect square number cannot be divisible by a perfect square number. So if it is a perfect square number, then the problem happen, it is very small, only 49, which is not divisible by 169. And if it is not a perfect square number, then it is not divisible by a perfect square number. So in both cases it is not divisible by perfect square number. Now second cases happened in case 2. We assume that the 13, our number 13 will divide. In case 2, we assume that in case 2 we assume that 13 divides n plus 1. So n plus 1 is what type of number? 13 times of suppose some lambda, or you can say mu, where lambda belongs to integer. So n plus 1, if I am doing squaring, we are getting 169 times of lambda square. So this type of number, so this is the product of two number, product of two integers, so we can say that 169 divides n plus 1 whole square. So if it is divide n plus 1 whole square and you are going to add something with it, that number is not divisible by 169. Again 169 cannot divide this number 13. So you can say that 169 totally, if you add this number n plus 1 whole square plus 13, is not divisible by 169. The reason is what? Minimum you have to add the multiple of 169 or 2 into 169, so that this number will also be divisible by 169, then the total number will be divisible. So in both cases you notice that this number 169 cannot divide. So in both cases, therefore we can say that 169 will not divide n plus 1 whole square plus 13 in all cases. So that means 169 does not divide n square plus 2n plus 14 for all n belongs to natural number or integer, whatever you want you can take. So hence proof. Is it clear? Any doubt regarding this you can ask me. Any doubt regarding this you can ask me. Now try to solve one more questions. Question number 5. 121 does not divide this expression n square plus 3n plus 5 for all n belongs to natural number. So here 121, again you notice that 121 is the 11 square. So in this expression, if I call this expression is E, so E is equal to n square plus 3n plus 5. So in this expression we have to bring 11 times of mu type number, mu type constant. That means multiple of 11 we have to bring here, where mu belongs to some integer n. So what we want to introduce here, because our constant is 5 only and 121 is a perfect square, which is a square of 11, so some multiple of 11, that is 11, 22, 33, 44 or 55, this type of constant we have to introduce here. So now here n square plus 3n present, so you cannot get a square of n. Perfect square of n we can't get. So in this case you have to do the factorizations of e. So we have to factorize e in such a way so that we will get multiple of 11 as a constant, multiple of 11 as a constant number, multiple of 11 as a constant we want. Okay, now so now these things I can write, this expression e, I'm going to write n square plus 3n plus 5. So here we have to use some trick. So that we get multiple of 11 as a factor. So if you are writing here, it is suppose n square. If you do the factorization in this way, n into, suppose you are taking 3 plus 2, so n into plus 2 you are taking, plus 1 into n plus something, suppose you are taking 2 again. So what will happen, n square plus 2n plus n plus 2 plus 3. So here you are getting 3, which is not a multiple of 11. Okay, now so now this breakup 3 plus 2 is not working here. So in this way you have to thought, so that we can get as a constant here 11. So I am taking 3 plus 2 plus 1 not working, then 8 and 5 if I take, what will happen, n square, if I am writing here 8n, then so n common, n plus 8, so here will be 1, n plus 8 is required. So here n square plus 8n, but I required 5, so it will be minus 5n, then minus 40, then plus 40 we have to add, then 45. So what we are getting, 45 we are getting, but this 45 is again not a multiple of 11, so this is also not working. Okay, now try to take n square. If I am taking here 7n, so n common, n plus 7, so here also 1 n plus 7 will come, n square plus 7n, but I required 3n, so multiply by 4, so it will be minus 4n minus 28. So we have to add plus 28 and then 5. Yes, this is working. So what we have to write, n plus 7 and n minus 4. So here you are getting one extra term, that is minus 28. So you have to add plus 28, 5 is there. So now you have n plus 7 and n minus 4 plus 33. So what you notice that this expression e here, this term, this is divisible by 11. This is divisible by 11. So now if you want to make this 11, if 11 divides e, then 11 must divides n plus 7 into n minus 4, as the reason is 11 divides, the reason is what, the 11 divides, the reason is 11 divides 33. 11 divides 33. So now since 11 divide this number, so what will happen, so this expression I call as beta. So beta I have n plus 7 and n minus 4, this type of number. So now if 11 divide this number, then what will happen, 11 divides any one of the factor, So suppose if I choose here n is equal to 1, so it is 8 and it is minus 3. If I took here 2, it will be what? 7 plus 2 9, then 2 minus 4 minus 2. If I am taking n is equal to 3, so it will be 10 and here minus 1. If I take 4, so this will be what? 11 into 0. If I take 5, then it is 12, and then we have 5 minus 4, that is 2, like this. So here in this way, if you choose n is equal to, suppose 16, 15, if I am taking, then beta value will be what? 22, and 15 minus 4 11. So one thing you can notice that always happen here, that if you consider the first number is divisible by 11, then the second factor is also divisible by 11. So if you consider first number, so let 11 divides any one of the factor. I am taking n plus 7. So in that time it will implies that 11 divide that number also, because their difference is, if you notice their difference, n plus 7 minus of n minus 4, that is nothing but 11. So it is a multiple of their difference is a 11. So if you consider first number is divisible by 11, obviously the second number also divisible by 11. So this is divisible by 11. So now we can say that what? 11 divides beta. But beta is what type of number? So you can say that 11 is beta, but beta, what we notice that both the factor divisible by 11. So we can write in this way. So therefore we can write our beta value is sum times of 11x into 11y, where x and y belongs to some integer. So that means it is 11 square 121xy. So now our e will become 121xy plus 33. So what we say that 121 divides 121xy, because here 121 present, but since you are adding some factor, which is not a multiple of 121, 121 is not a multiple of 121, this 33. So you can say that after adding this number, this will not divide. I hope this is clear to all. So for every value of n, we notice that this expression is not divisible by 121. So 121 does not divides n square plus 3n plus 5 for all n belongs to natural number. Hope this is clear to all. Now next is question number 6. It is also a very beautiful questions. This question came in RMO 2012. Question says that if 13 divides n square plus 3n plus 51, then prove that 13 square divides, it will implies 13 square divides 21n square plus 89n and 44. Again listen, if 13 divides n square plus 3n plus 51, then 13 square also divides 21n square, 89n and 44. So now our journey started from here, from the first expression. So 13 divides n square plus 3n plus 51. Remember, if I consider this expression is e, so we have to express or factorize e in such a way so that our constant will be multiple of 13 into some integer. This should be the constant, otherwise we cannot solve this question. Okay now. So now here again the same logic we have to apply, that we apply here by doing in the heat and trial method. We have to introduce some factor here so that the constant will be the multiple of 13. Okay now. So if I take here 8 and 5, so now you are getting here minus 40, so it is plus 40, then 51. So now n plus 8, n minus 5 plus 91. So this expression, this number is divisible by 13. This number is divisible by 13. Okay now. So what we can say that, what about this number? 9 plus 8 and 9 minus 5. So since 13 divides E, so we can say that 13 must divide n plus 8 and n minus 5. If you consider any one of the factor is divisible by 13, then the other factor is also divisible by 13. The reason is what? If 13 divides n plus 8, just like the previous sums, so this will implies 13 divides, just like the previous sum, 13 divides n minus 5 as their difference n plus 8 minus of n minus 5 is nothing but 13. So now we can write as since 13 divides n plus 8, so we can write n plus 8 is equal to 13x, or you can say that lambda, some lambda or mu we want to introduce. So you can say that, or you can say that it is p, and n minus 5 is divisible by 13, so n minus 5 is equal to 13q. So here p and q are the some integers. So now with the help of this n plus 8, n minus 5 are the some factor, you have to prove that this another factor which I called f, this expression 21n square plus 89n and plus 44, this is divisible by this 13 square. Okay now. So now here 21 gives you the factor 3 and 7. From 44 you are getting 4 and 11. 4 means 2 into 2 and here 11. So now 2, 2, 3, 7 and 11. You have to bring 89. 4, 12. 12 plus 77 is what? 89. So now 21 n square plus 12n plus 77n plus 44. So from here you can take 3 common, 3n, 7n plus 4. From here take 11 common, so 7n plus 4. So 7n plus 1 is one factor and 3n plus 11 is another factor. Okay now. Okay. Now what we want to do, here we want to introduce these results here. We want to introduce these results we want to introduce in these factors. So how can we do this? How can we solve? Okay, now. So that here we are getting the one factor is 13. Here from we are getting one factor 13 into 13 169. This is our target. Okay now. So how we can introduce this? N plus 8 n minus 5, n plus 8 n minus 5. So now if I consider one factor is n plus 8, another factor is n minus 5. So here I have to bring 7. 7 means if I consider here 4, so it will be 4n then 32, and if it is 3 then it is 3n and minus 15. So 32 minus 15, not 11, 4 not coming. So now if I consider this one is 3, this one is 3 and this one is 4, will it work? 3 and 4. So 3n plus 24 and then 4n minus 20. Yes, this factor you can write as 3 times of n plus 8 and 4 times of n minus 5. Okay now. Now coming to this part, this you can write as n plus 8 if I am taking, and one is n minus 5. So 11 I want to bring, so 2 and 1. So 2 times of n plus 8 and 1 times of n minus 5. So now here we have 3 into 13 x, then 4 times of 13y q, not x, it is p, and here we have 2 times of 13 p plus 13q. So 13 we are taking common, so it will be what, 13 square, it will be 3 times of p, 4 times of q, 2 times of p and q. So this result will be 169, and this will be m, if I consider m is the product of these two integers. Okay now, so what we notice that 13 square divides the expression a, hence proved. Hope all of you understand this concept. Question number 6 completed. Acha, before doing these questions, one important result we want to prove. One result is there. Prove that product of r consecutive integers is divisible by r factorial. Prove that product of r consecutive natural number or the integer, positive integers, if you take negative we consider only positive, is divisible by r factorial. That means if you are taking three integers which are consecutive, so 3, 4 and 5, so you notice that this result is divisible by 6, 3 factorial, because 3 factorial is 6 and here you are getting 12 into 5, 60, which is divisible by 6. So now we have to prove this result in a general way. Now all of you know that NCR is an integer. NCR is an integer where it is defined. So what we are taking, n, r is lesser than equal to n and greater than 0. R is greater than equal to 0. Okay now, so this is the restriction where r and n both are integer, r and n both integers, both, or you can write the full restriction. So this is the restriction 1. Now number 1, n belongs to natural number. Number 2, r belongs to whole number. Number 3, n 0 lesser than equal to r, lesser than equal to n. So these 3 criteria will be fulfilled. Then we know that NCR is always a integer. NCR is always integer. So now NCR we can write as n factorial by r factorial into n minus r factorial. N factorial is what? N into n minus 1, n minus 2. In this way, if I am taking r places, so it will be n minus r plus 1, then n minus r, then n minus r, n minus r minus 1. In this way, final is 3, 2 and 1. In the lower part, what we have? R factorial and n minus r factorial. This part is the left part is the integer. So now from here, n to n minus r plus 1, these are the product of r consecutive integers. Product of r consecutive integers. Product of r consecutive integers. If I write by the notation p, so now it is p and the remaining part is nothing but n minus r factorial divided by r factorial into n minus r factorial, because 1, 2, 3 up to n minus r, so in the factorial notation it will be n minus r factorial. These two cancel out. What we have? P by r factorial, which is nothing but an integer. So it will implies by the definition of divisibility, we know that r factorial divides this product p. So we have the general proof of these results also with the help of these combinations. Okay now we are going to solve few questions on the basis of this. Question number 7, prove that prove that 120 divides this number, this expression n power 5 5n cube plus 4n, where n is greater than equal to 1. So now we take this expression n power 5 5n cube plus 4n as e. Take n common, so it will be n square minus 5n, it is n4 5n square plus 4. So here we are doing the factorization. Here we will do the factorization, n power 4 minus this one. So n into it is n power 4 minus 4n square minus n square plus 4. N times of n square common, so n square minus 4, then you have minus 1 n square minus 4. So now n times of n square minus 4, then we have n square minus 1. Now n times of n plus 2, n minus 2, n plus 1 multiply with n minus 1. If you arrange this, you are getting n minus 2, then you have n minus 1, then 1 more than n, then again 1 more n plus 1, again 1 more n plus 2. So what you are noticing that these are the product of 5 consecutive integers, product of 5 consecutive integers. So therefore by the property 5 factorial divides e. 5 factorial means what? 120 divides e. Hence proved. I hope all of you understand this concept. Now try to solve this one. Question is prove that 6 divides n cube minus n for all n belongs to natural number. So now we can write in this way, e is equal to, let e is equal to n cube minus n. Take n common, so it will be n square minus 1, n into n plus 1, n minus 1. So therefore you can arrange it, it is n minus 1, then n, and then n plus 1. So this is nothing but product of 3 consecutive integers. So this is divisible by 3 factorial. So 3 factorial divides e, it implies 6 divides e. Hence proved. Now coming to the next one, that is question number 9. Prove that 24 divides n into n square minus 1 and then 3n plus 2. So here you notice that 24 is nothing but 4 factorial. So now we consider e is equal to the given expression n into n square minus 1, 3n plus 2. So this is n into n plus 1 and then n minus 1. And here we have 3n plus 2. So now n minus 1, then we have n, then we have n plus 1. Next integer will be n plus 2. So for n plus 2 I am writing here n plus 2. Now it is what? 3n plus 6, but 2 is present, that means minus 4. So it will be n minus 1, then n, and then n plus 1, and then product 3 into n plus 2, and then 4 times of n minus 1, n and n plus 1. So this number is product of 3 consecutive integers divisible by 3 factorials and multiply with 4. So this will imply divisible by 24. So 4 into 6, 24. So here this expression is divisible by 24, and here the product of 4 consecutive natural number divisible by 4 factorial, which is 24. So both the expression divisible by 24. So we know this property, if a divides b and a divides c, so this will imply a divides bx plus cy for some integer x comma y belongs to integers. So therefore we can say that 24 divides E. Hence proved. Now guys, we have completed the basic properties of the divisibility, and we have done so many questions which came in the competitive exams like pre-RMO, RMO. So in the next video we are going to solve more questions on the divisibility. We will learn the divisions algorithms and some standard results we will do. Then we will then we'll go to the next topic. Okay now. So now thank you for watching my channels and be in touch with me. And if you have any queries, any doubt, please send me in my inbox. Okay now. I hope all of you enjoy this session that is based on the number theory, and for this is suitable for all the students from class 8 to 12 and those who are especially preparing for IOQM. These are very beneficial for them. Now we will meet in the next video. Till then, bye. Have a nice day.